Welcome back. Today we're going to be discussing bone growth. And there are two main types of bone growth. Interstitial growth, which is the growth in length of the bones, and that happens during childhood and adolescence. And appositional growth, which is the growth in width of the bones. And that's going to happen also somewhat during childhood and adolescence, but also throughout the rest of life. We're going to try to use claymation to show you how bones grow. You can see here that I have created a bone. This bone is going to grow. The white part is the calcified bone material. The yellow parts are the cartilage, the hyaline cartilage that are the growth plates for the bone. And you can see that we have two growth plates, one on the proximal end and one on the distal end of this bone. And they attach the diaphysis with the medullary cavity in the middle to the proximal epiphysis and the distal epiphysis. Bones grow in length by depositing new cartilage and then calcifying that cartilage and then ossifying that cartilage so it becomes bone. So the first step in growing a bone in length is to recruit chondroblasts in to lay down new cartilage. You can see the green beads coming in to represent the chondroblasts, and they're going to lay down a layer of new cartilage. At the same time, osteoblasts are going to come in on the opposite end of the cartilage, on the diaphysis end, and they're going to start ossifying the old cartilage, making it into bone. And for a while, the cycle repeats. The chondroblasts build new cartilage, the osteoblasts turn that cartilage into bone, and they sort of keep up with each other. Each time we add new cartilage, it pushes the epiphysis away on both ends, and the bone grows in length. As the bone grows, we have to extend the medullary cavity, and so osteoclasts, the blue beads, come in and break down bone, extending the medullary cavity so that the blood vessels and nerves can reach further up towards the epiphysis. During puberty, the sex hormones, estrogen and testosterone, activate the osteoblasts so that they put down bone faster than the chondroblasts are putting down cartilage. And so the bone starts catching up. This causes the growth plate to slowly get smaller and smaller and eventually close. At the end, you're left with a very, very thin line of hyaline cartilage, and so the epiphyseal plate becomes the epiphyseal line. This will eventually also become ossified, and there will be no more cartilage left to extend the bone. Appositional growth is the growth in the thickness of the bone, and this can happen anytime throughout life, during bone remodeling or when greater loads are placed on the bone so it needs to be wider and thicker. And instead of using hyaline cartilage, we are just using osteoblasts that are putting down new bone material. As the bone grows, new blood vessels come up between the bone, the diaphysis, and the periosteum, which is the connective tissue covering of the bone. These blood vessels bring in osteoblasts, which lay down new layers of bone around the diaphysis. The bone is laid down underneath the periosteum, the connective tissue covering around the bone. Osteoclasts, the blue beads here, come into the medullary cavity and scrape away bone, breaking it down to make the medullary cavity bigger so more blood vessels can fit into it. We can continue to lay down new layers of bone by recruiting osteoblasts and letting them put new bone material on the outside of the bone. Osteoclasts will continue to break down bone in the medullary cavity to maintain normal weight of the bone and keep it from getting so heavy. Also, to give room for blood vessels and nerves to run through the medullary cavity. That's it for today. See you in class.